Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to take a look at the standard subtraction algorithm used here in the US. Now, if you notice, the first word is understanding, and I hope you'll stay with me throughout the video because I will share with you some ways that we build the understanding piece of the standard algorithm. Now, this understanding piece is important for some children who really struggle to remember just rules and procedures. It doesn't make sense to them. The language we'll use, that understanding will help them. But more importantly, this link will help them when they get to subtraction of mixed numbers, subtraction with regrouping that way. Now, when I was young, we used words like borrowing. You borrowed from the column next door. Now you may be hearing words like regrouping. But again, it's not just important for whole number subtraction. It will be important for mixed number, for decimal, as they're thinking through subtraction as they go up through the grades. Now you see, I have some models here linked with subtraction that your children may be using. We have base 10 models. Now these are the commercial ones. You can see the 100, the 10, the 1. I also have some paper ones that I use with children. These are made out of centimeter grid paper, hundreds, tens, and ones. And what's important as we start to use these models is helping your child understand equivalent ways to make the same quantity using tens and ones, 100 tens and ones, wholes, halves, and sixths, but getting that idea that I could make 25 using 2 tens and 5 ones. That's the place value. We think of 2 as in the tens place, 2 tens, 5 is in the ones place. But I could also make 25 using 1 10 and 15 ones. I could make it using 25 ones. Think about currency, our quarter, right? I could have 25 cents with a quarter. I could also make it with 25 pennies. I could make it with 2 dimes and 5 pennies, 1 dime and 15 pennies. It's the same idea. It's about equivalency. So you may see your children being asked to think in terms of equivalent ways to make the same quantity. Now I'd like us to we'll look at 62. And if I think of what are some ways I could make 62 using tens and ones. Now there's lots of ways I could do it using addition, subtraction, multiplication, division, but we're just going to use tens and ones for this. I could make it thinking in terms of place value, 6 tens and 2 ones. I could make it with 62 ones, right? And we'll use language, and in the addition algorithm language, we talked about which one uses the fewest number of pieces and which one uses the most pieces. I'm going to need 62 ones, or think about if I were making 62 cents, 62 pennies, that would use the most coins to make that. But now there are other ways I could make 62. I could make it with 5 tens and 12 ones. I could make it with 3 tens and 32 ones, or 1 10 and 52 ones. 4 tens and 22 ones. You get the idea, right? And for the children, they start to play around with the numbers and get more and more comfortable with equivalent ways to make 62. Now, this becomes really important when we start to do subtraction, regrouping type problems. Now, here's a problem here that does not require regrouping. I'm going to remove 1 of the ones and 3 of the tens from this, right? So the standard algorithm, we work right to left. So 2 ones, remove 1 of them. 6 tens, remove 3 of them. There I am. But let's say I change this. See, in this case, I don't have enough ones to remove 9 ones. I can remove 2 of them, but I can't remove 9 of them using this standard algorithm. So I need to think of an equivalent way to make 62. Well, what's an equivalent way that's helpful? This one, right? I could make 62 with 5 tens and 12 ones. See, we want to get your child thinking in terms of equivalency, because once I have that, well, if I remove 9 of those ones, I'll have 3. If I remove 2 of the 10s, I'll have 3 10s left. Now, do you notice how I keep talking about place value each time I'm doing this algorithm? Doing the algorithm from this, or the procedure from this understanding point of view, helps us continue to review place value. When I learned the algorithm, you ignored place value, really. You were just focusing on every place like it was the ones place. And so I was having to learn place value separate from learning how to combine or remove quantities, okay? So here we really want equivalency. You may find that your children are asked to think in terms of equivalency, right? I could do it in terms of hundreds, tens, and ones. Think about a number like 341. Could have that with 3 hundreds, 4 tens, and 1 1. 341 ones, 34 tens, and a 1. I could do it with 2 hundreds, 13 tens, and 11 ones. See, that comfort, and I might need this one when I do certain regrouping type problems with subtraction. Think about a problem like this. See, I need to think of an equivalent way because I don't have enough ones and I don't have enough tens. So what's an equivalent way I could make 341? Well, I could make it with 2 hundreds, 13 tens, and 11 ones. Okay, an equivalent way to make it. That would let me remove these amounts. So I'm always thinking place value. I can use the same idea when I am doing decimal subtraction. But as I said at the beginning, this idea of equivalency becomes very important as your child gets into mixed number subtraction. Let's do a simple problem, even if I just do 5 and 1 6, and we're going to remove 2 and 5 6. Now, there are other videos available that show you other strategies your children might be learning, things like round and adjust, decompose quantities, decompose a place. But this is that standard algorithm, which would have us go from right to left, right? But I have to think of an equivalent way. And if your children have only been thinking in terms of borrowing a 1, like I learned, you might see them do something like this. They overgeneralize. They'll overgeneralize that algorithm and start moving a 1 over. And this is incorrect, right? I need to think of an equivalent way to make 5 and 1 6 that will give me more 6. So how can I make it? I could make it with 4 wholes and 5 1/6 pieces. Sorry, 7 1/6 pieces. I'm thinking of the 4, right? Sorry about that. So I could make it with 4 wholes and 7 1/6 pieces, which would let me remove 5 of the 1/6. So I'll have 2 1/6 pieces. And then 4 wholes remove 2 wholes give me this. Now, what's an equivalent way? I could make this using fewer pieces. See, remember that most and fewest I showed in the 62 ways to make 62? Same idea. How could I make this using fewer pieces with 2 wholes and a 1/3 piece? So this equivalency idea, thinking of 5 of 1/6 as the same as 4 and 7/6, equivalent to 4 and 7/6, really an important concept. But it will begin with having your child start to play around with equivalent ways to make the same numbers. So it's not just a rule that they're doing, but understanding behind the rule so that when they get here, they don't make this mistake. I hope you found this video helpful. If so, please give it a thumbs up, share with others who might find it helpful. Please consider subscribing to the channel. It really helps us out. It's free, so you can just go to the channel, subscribe, click on the notifications bell, then you'll get a notification when new videos are posted. I try to post each week on a Tuesday afternoon, but during the summer months that we're going into now, I'll start to move to doing it once every 2 weeks and then start back to once a week when the school year starts again here. So thanks so much for watching. Again, thumbs up, share, subscribe, notifications bell. I hope to see you in other videos. Please check the description below for other links to videos that are linked to this idea and may be helpful to you too. See you next time.